This example shows how to use Visual Slope V7 to design a shoring system for a staged excavation. First, create a new project and go to the setting page. Input the titles, select the right units and define the range of the model. In the Visual Slope main page, let's set up material properties first. To save time, we import material properties from material banks. First, import soil properties. Then, import tieback data. Then, import retaining wall properties. Now, let's see the details of material properties. For tiebacks, the input data include tieback name, hole diameter, horizontal spacing, tendon capacity, head capacity. EA is not required for shoring design. Soil properties include those used in slope stability analyses, plus elastic modulus and Poisson's ratio. Retaining wall data include only wall name and bending modulus. After material properties have been set up, we will use shoring system generator to generate the model. In the shoring generator page, first input the wall coordinates, and back slope data. Visual Slope allows wall section to vary with the depth. Select wall sections from top to bottom. Now, let's set up ground data from top to bottom. Type in the elevation and then choose the material below. Set up bracing data from top to bottom. Bracing data include elevation, stiffness, preload, and horizontal spacing. Next, set up excavation stages, which include excavation elevation, front water table elevation, backwater table elevation, and surcharge. The first excavation elevation must be the same as the top of the wall elevation to represent the initial conditions. The user must click the Stage Setup button to confirm above input data before go to the next step. The next step is to set up the relation of excavation stage and bracing. The list on the left shows bracings available to use, and the list on the right shows the bracings used. The arrow keys can be used to move bracing from the left to right or vice versa. If the bracing is in a preload stage, double-click the bracing on the right. After the stages have been set up, each stage can be previewed. The first stage is the initial condition. The second stage is in a preload condition. The final stage includes all 5 layers of bracing. Now, the model setup has been completed. Next is to perform analyses for each stage. In the analysis page, if include ground option is chosen, the ground deformation will be calculated along with the internal forces and deflection of the retaining wall. Once include ground option is chosen, analysis must be conducted stage by stage. The first stage only calculates the initial condition. The second stage calculates the preload condition. The results will show bending moment, shear force, wall deflection, and so on. The ground movement will also be calculated with the 2D finite element method. The detailed ground movement can be shown. We can continue with the same process. To save time, we will not calculate the last stage, but show how to design a shoring system with tiebacks. Let's preview each stage. In the preview, the length and angle for each tieback are the same, but they can be changed before analysis. Analyses for a tieback wall are similar to a front braced wall, except for the tieback properties must be assigned to the tieback for each stage. Visual slope allows to use different types of back pressure, active, at rest, program-defined, user-defined and so on. The program-defined pressure is based on 0.65 gamma h. The user can also ask visual slope to adjust the length of tieback to meet the safety requirements. If you do not wish to run a staged analysis, you can uncheck Include Ground option and choose Staged Excavation off. Then you pick a stage to calculate without considering the previous stages. You can also edit the design code. This concludes this presentation. Thanks for watching.